Okay, so as promised, I'm going over the last word problem that we didn't get a chance to get to because we were hard working on these examples. So let's get started. We're solving systems of equations using word problem in a word problem, and we're doing this algebraically. So the problem says the school that Giovanni goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior tickets and 2 child tickets. We want to find the price of a senior citizen ticket and the price of a child ticket. So let's break down the information in this problem. So the school is selling tickets, and they sold tickets on 2 days. So we'll name those 2 days. This is the first day, and this is the second day. And we know that there are 2 types of tickets that they're selling. They're selling a senior citizen ticket, and they're selling a child ticket. I'm going to assign each one of these types of tickets a variable, okay? So let's call that senior citizens ticket, let's call it S, and we'll call that child ticket, we'll call it a C. And you can think of this as like our X and our Y, right? And if it's less confusing, I can actually rewrite those variables as X and Y because I don't want you guys to be confused by me using different variables. So you know what? I'll go ahead and change that just so that y'all aren't confused. This S will be our X, and we'll make that child ticket the Y because I don't want y'all to get confused. So no worries. We'll just say that the senior citizen ticket represents the X and the child ticket represents the Y. So what's happening? Well, on the first day, they sold, according to our information. And let me move my face out the way because I feel like it's in the way. All right, the first day we sold 3 senior citizen tickets and 1 child ticket. So 3 senior citizen tickets. So that's 3X because the X represents the senior citizen tickets. And we sold 1 child ticket. So that's just 1Y. And that came to a total profit of $38. Okay. Then on the second day, they sold 3 senior tickets. So that's 3X's. But they sold 2 child tickets. So 2Ys. And they made a profit that day of $52. So what we want to know is, well, how much does each senior citizen ticket cost and how much does each child ticket cost? Well, in order to find that, we would need to find the solution for the system of equations. And so what we can do is we can either use that substitution method that we talked about today or that elimination method. Well, let me tell you something. When I have a situation like this where I have 2 equations where I don't have them set up so that I know what one is equal to, then I typically do the elimination method. So I'm going to just set it up for the method 2, which is the elimination method. And so I'm going to stack these equations according to their like values, their like terms. So I've got first day and I've got second day here, and they're stacked according to like terms. Okay. So my X's on top of my X's, my Y's on top of my Y's, and then my constants on top of each other. Well, I know in order to use the elimination method that I have to meet 2 criteria, right? So I need for my variable to either have the same they have to have the same coefficient, and they have to have opposite signs. Well, when I look at my variables, I see that the X's have the same coefficient. So it meets one of my criteria, right? but they're not opposite signs. So I want to make sure that they end up being opposite signs. So what I can do is I can multiply one of those equations by -1. So when I multiply that bottom equation by -1, I'll end up with the top one we didn't mess with, so that's the same. But this bottom one will now be -3x. -1 times 1 is -y. And then this will be -38. Now that I have the same coefficient for my variable and opposite signs, I know I'm ready to combine them. And what will happen is when I combine, my x variable will be eliminated. And then I can combine my y variable. Well, 2 positive y plus 1 negative y will leave us with 1 positive y. And then 52 plus -38 would result in us having a difference of 14, right? And so I've got y is equal to 14. But I also want to figure out what my x is. So I'm going to take this y value and sub it in to one of the equations. So I'm going to take that 3x plus 2y, that equation right there, equals 52. And I'm going to sub in this y value for where I see y in the equation. So it'll be 3x plus 2 times 14 equals 52. And now I just solve for x. So I've got 3x plus, that'll be 28, is equal to 52. Well, I'm going to subtract 28 from both sides so that I'm left with 3x is equal to, and that's going to give us, well, 52 minus 28. Let me pull up a calculator real quick. Pardon me for not being prepared. 52 minus 28, bam, that gives me 24. And then I can divide by 3, and that'll leave me with x is equal to 8. So I have x is equal to 8 and y is equal to 14. And I want to make sure that that works for the other equation. So I'm going to plug both the x and the y back into the other equation. So this 3x plus y. So let me check by plugging in to the 3x plus y equals 38. So my x value is 8. So 3 times 8 plus the y, which would be 14. And we want to make sure that the left side matches the right side. So 3 times 8 is 24 plus 14. Will that give us 38? Yes, it does. So it satisfies both equations. So that means that my solution for this problem is x is equal to 8, y is equal to 14. Well, we can't just write our answer as 814. Like, that doesn't make sense for this real world application. So we have to think about, well, what does our x and our y represent? Well, our x, if you remember, represents the cost of the senior citizens ticket. So essentially, that means that the senior citizen ticket is $8. So they're charging $8 for a senior citizen ticket. And then for a child ticket, remember that represented our Y, a child's ticket represents 14. So it costs $14. And if you can remember, that's what they asked us. They said, find the price of the senior citizen ticket and the price of the child's ticket. Well, the price of the senior citizen ticket is $8 and the price of the child ticket is $14. So we've answered the problem. I hope this helps. Good luck on your exit ticket.